Hi everyone, my name is Vicky. I am a chemistry major and I will be presenting my material science project on epoxy resin. So epoxy resin is the most commonly used form of synthetic resin. It is a complex synthetic polymer made to mimic its natural counterpart. Epoxy resin is most commonly recognized as a clear viscous liquid that dries to make beautiful art pieces, such as the one shown on this slide. However, it also has many other applications, especially as additives to other polymers due to its various qualities such as high strength, effective electrical insulation, ability to thermoset, low cost, low toxicity, and reactivity, each of which I will go into more detail on the next slide. So, epoxy resin today is most often used in dental material, artwork, coatings, adhesives, and electronic boards, precisely because of the characteristics that I have just listed. Epoxy resin has had a relatively short history. A Russian chemist named Prilazov, and please excuse me if I mispronounce any of these words, was the first to observe that olefins or alkenes would react with preoxybenzoic acid. The reaction forms epoxides, which are then used to form epoxy, along with polyamine. This is later coined as the Prilazov's reaction. In the mid-1930s, a German scientist named Dr. Schallack was granted a patent in which he prepared a polyamine with a high molecular weight. Schallack was able to achieve this through the use of epoxide compounds, which contained more than one epoxide group. The first epoxy, as it is today, wasn't synthesized until 6 years later, when Dr. Pierre Castan from Switzerland and Dr. S.O. Greenlee from the US both recognized the chemistry of epoxy that people use today. They both applied for different patents during the late 1930s. Dr. Pierre Castan allowed his work to be licensed by a company named Ciba in Switzerland. Ciba soon became the first company to commercialize the production of epoxy resin in 1946. Aerospace was the first commercial field that epoxies would penetrate into in the early 1950s. It would then take well over 2 decades for epoxy resin to finally get the exposure that it has today. Now, when epoxy resin or epoxy was first introduced to the market, it was extremely difficult to describe what exactly it was. 3 major innovations, especially in recent years, have contributed to our further understanding of epoxy resin and its possible uses. The first innovation involved integrating epoxy into varnish that's used for laminates. Nanya Plastics currently owns the patent for epoxy resin varnish. This epoxy composition has a high glass transition temperature due to increases in the cross-linking density of the resin. This led to further development into improving the mechanical strength and heat resistance of epoxy resin and varnish. This innovation was rather groundbreaking, as the epoxy resin composition offers low water absorption and excellent heat resistance to electrical laminates. With this new discovery, even fire retardant requirements were able to be fulfilled at relatively low cost. The second innovation involved using epoxy resin in solvated solids. This took the curing process to the next level and enhanced the thermal, mechanical, and chemical properties of epoxy resin. Therefore, epoxy resin became highly useful in the manufacturing of composite parts by vendors. Air Products and Chemicals Inc. now owns the patent for this composition. The third innovation involves the preparation of stable aqueous epoxy resin dispersion. This patent is currently owned by Dow Global Technologies. This process is solvent-free and uses polyvinyl alcohol as a primary dispersant. Properties like low volatile content and low viscosity, which are highly desirable in the coatings industry, are inherent in this new dispersion. Alright, so epoxy resin, epoxy, or epoxide all refer to a broad group of reactive compounds that are characterized by the presence of an oxy ring or epoxy ring, the 3-member ring containing an oxygen atom bonded to 2 alkyl groups, as shown. As shown here. Epoxy resins are often combined with various curing agents and modifiers to achieve the properties required for a desired specific application. Typically, this involves the reaction of compounds containing at least 2 active hydrogen atoms, such as diamines and aminophenols, with epichlorohydrin. So here would be the phenols, and this compound would be the epichlorohydrin. The reaction here shows the specific synthesis of the most common type of epoxy resin monomer. So within the brackets would be the monomer, and to become a polymer, as shown by this chemical structure, would require that monomer being repeatedly attached to itself over and over again. The reaction here specifically shows the most common type of epoxy resin monomer, which is produced from bisphenol acid and epichlorohydrin. Sodium hydroxide over here is added as a catalyst. The hydroxide will react with each of the alcohol groups on this compound, creating two polarly negative ends. With a formal charge of -1, the oxygen atoms want to donate or share the electron densities. They're able to do this with one of the carbon atoms on epichlorohydrin, specifically this carbon, which causes the bond between the carbon and chlorine atoms to break, releasing the chlorine atom. How big or small the polymer gets depends on the ratio of epichlorohydrin to bisphenol acid in the reaction mixture. Alright, so for closing thoughts, I typically came to know resin as something that's used in artworks and craft projects, so I was very surprised to find the use of resin in various everyday objects, such as varnish, coating, and even electronic boards. It was very intriguing to learn how epoxy resin is most often not used by itself, and instead acts as an additive component to something for added strength. Specifically while doing my research, it also surprised me how relatively easy I was able to understand the reaction mechanisms shown for epoxy resin. I was eager and glad to be able to smoothly apply what I have learned this far in this class. And overall, it has been a very enjoyable project and has prompted me to do more research about material science, especially involving the various compounds that we use in our everyday lives. Yep. And here were the references used during my presentation as cited for my images, diagrams, and collected information. Yeah. Thank you so much for listening.